What do we think our unit for heat is going to be?
Fahrenheit. Celsius.
For what?
Heat.
Not Fahrenheit, not Celsius, not Kelvin, not degrees.
Would it just be energy?
1 minute.
Energy.
Yeah, so
Heat is
joules.
energy. So what's my unit for energy?
Joules.
Joules. Perfect, perfect. My unit for Q then will be the joule. Again, not the joule, but the joule. What's my unit for mass? Kilograms. Every single time except this time. Oof. It's going to be grams. Why, Mr. Lewis? You're just changing it
Because
all up on us.
it's a chemistry thing instead of a physics thing.
Avogadro's number.
Yeah.
Avogadro's number. That type of idea. You guys will get that in chemistry. But we're going to use grams because of our unit for C. C is the specific heat. It's a constant. Lead will always be 0.13 joules per gram per Celsius. Granite will always be 0.79 joules per gram per Celsius. So to allow our units to match, we have to use grams for our mass.
Uh-huh.
With these?
Yep.
Specific heat we said was joules per gram per Celsius. And then temperature, we're going to have that in degrees Celsius. Okay? Degrees Celsius. MCAT equation. MCAT. Get it? MCAT. Yeah.
No.
So what this looks like then, nice practice pool. We have an iron skillet. We're making some eggs in the morning. The boys came over for the weekend. Not the lady, but the boys.
Is it Saturday?
Right, there's no sleepovers between us and Jeffrey.
Saturday was for the homies.
Saturday for the homies, Saturday for the boys.
Walmart lady didn't get to spend the night.
What?
I said,
What?
Walmart lady didn't get to spend the night, man.
They're not doing sleepovers.
Yeah, heck no, we're not.
They're going FaceTime.
We'll FaceTime. Yeah. Only the boys. You gotta get the boy that actually knows how to make breakfast, so you don't have to make it.
You still get snacks for it.
Or you go to the house where mom's still making breakfast for you. Yeah, you know. Making the pancakes, blueberries. So our iron skillet has a mass of 500 grams. The specific heat of iron we know is 0.449. How much heat must be absorbed to raise the skillet's temperature by 95 degrees Celsius? Well, what do we know?
We plug the 500.449 in parentheses.
So we know the mass is 500 grams. We know my C is 0.449. We know my change in temperature, all of delta T, is going to be 95. Plug and chug. We're looking for Q. Q equals mass 500. C we said is 0.449. Delta T is 95. You get some number.
You could get. Why is it 95?
So let's say the iron skillet started at 0 degrees Celsius. It was frozen. It has now ended at 95 degrees Celsius. Or maybe it started at 100 degrees Celsius and it's now ending at 95 degrees Celsius.
So the only time you do the TF minus TI is when there's two numbers.
Is when we're looking for one of the temperatures, correct? Or we're given two.
Okay.
Yep. So another way I could write this then, great question. Another way I could write that is TF minus TI equals 95. 21,000.
327.5.
How many sick things do I need?
Great. No. Yes.
Am I done? my unit? Joules. Not the joule, but the joule. Yes, no, maybe so? Sort of so.
Pretty groovy.
Groovy. Nice groovy.
Crazy.
Next problem here, we are wanting to know the mass of water if we heat it from 25 to 50 degrees with that many joules. Well, hold on. What mass of water can be heated from 25 to 50 using that many joules? So we're going to take a hot plate. We're going to take some amount of water and we're going to raise the water temperature from 25 degrees Celsius to 50 degrees Celsius. How much water is in the beaker? That's the question. What do we know?
Temperature is 25.
Change in temperature, so my final temperature is 50, my initial temperature is 25. We know that my Q is 2825.
We know the
Math?
content of water.
We know our specific heat of water is a number we're going to memorize. 4.18.
Are we actually gonna have to memorize that?
You just will.
It's gonna be amazing.
Well, you know, ladies and gents. MC delta T. Or I can write it as Q equals MC final temperature minus initial temperature.
Did you just add them together? I mean, subtract them.
We are going to. 2825 equals, that's what we're looking for. That's 1.8 times 50 minus 25. 2825 equals times 5. You get some number. Multiply, divide over, get it by itself.
27.03.
I'm done.
Nope. No.
3. What's my unit for mass? Grams when we're doing specific heat. Very nice, very, very nice. So I put 27 grams of water in a beaker, and I added 2,825 joules of energy, and I rose that water temperature 25 degrees. So, yes, no, maybe so?
Can you go back to the specific heat science?
This is when we're done from there, right?
Yeah. I'll give it a beat. So where are we going with this? Where are we going with this?
Thermodynamics.
Well, energy conservation, right? My firstborn child's name is
Conservation.
conservation.
Scientific entropy.
So we're gonna look at Q equals Q. And if we remember slapping chickens, we went from kinetic energy to thermal energy. That equation that we looked at the beginning of this unit is half mv squared equals Q equals mc delta T, right? We need the kinetic energy into thermal energy. Specific heat is good, specific heat is fun. It is really, really cool. So where we're going with this, I will eventually be handing you guys an unknown piece of metal. You're going to have to use calorimetry to figure out what that metal is. Calorimetry. Just like with the Leidenfrost effect, like Miss Nevins pointed out, the hot piece of metal transferred energy from the metal into the water. And we are going to test the
Exactly what
water
we did in
temperature and
Cap.
figure out what's kind of going on. And then find
It seems to
specific
boil
heat.
faster and
We're going to
over.
find our C value to figure out what metal is in our hands. That's where we're going with Christine. That's exciting. That's super exciting. We're
In
gonna
what
learn
way?
with it.
In one way.
Yep. That's why I kind of structured this. We will do thermodynamics tomorrow. Yeah. We'll do thermodynamics tomorrow. We'll do using heat. So Tuesday, Wednesday. Potentially Friday test over energy. Cool beans?
Groovy.
Yeah.
Cool. And then that gives us Monday and Tuesday and Wednesday to talk about waves. Final examples Thursday or Friday. Yeah, that'll be good. Yes? Please go.
Yeah.
Now that we're running out of time, we're right down to the wire.
Sunset still.
Eventually, before the test.
Okay.
I mean, you could be. You don't have to do it at all. Does it work 5 points? I don't want one. Can I like call this good and put some snow in a bucket and go home? I don't have a 5th hour. I don't want to be here. This is the longest I've been in school all year.
Honestly, I don't want to.
I'm also coming around with the second worksheet. This is Q equals Q. This worksheet will have to be completed before you can do the lab. So you have to know how to do the math before you do the lab.
So you're
Okay.
gonna need to do the math tomorrow?
Yeah, so we'll look at the math tomorrow for this worksheet, but I want to give it to you guys today. Because some of you guys might be able to figure it out. When I say might, you guys.
I wanna do that core one where you do that with the light bulb, and I wanna do that. That's what we wanted to do in the library.
Let's see.
With purchase.
Yeah, I really wanna see if it works.
See if it works.
Yeah, do you have a light bulb?
Yeah, do you have a light bulb?
You know what, yeah. Like one that we can hold on to.
Like a tube light bulb, like the one we had for the Vandegraaff generator?
I don't think that works. It's literally a normal light bulb.
Is it a Tic Tac?
Here, I'll show you. It's on TikTok. Well, it's on Instagram. Get it right. Hold on, I'm putting this person in the table.
Sure.
Never done it before. No. Yeah, someone else really never done it. Okay, I guess I'm playing 8 ball with someone else now. That was a terrible idea.
Yes, up top.
Someone posted my number on their story, so now there's a bunch of people.
Hi, Damien.
Hi, Kevin.
You know my name.
I do know your name.
What the heck happened?
Snow.
Really?
Yeah. It's cold.
Stop touching stuff. I don't know.
Did you really just
No, I did it on purpose.
snow? See if
Yeah.
it's hot or not?
No.
I told you it was hot.
Well, he put his finger like
Hey.
that
Hey,
and like
you don't know.
pulled it back. 'Cause thought the snow was gonna be hot.
Oh, no, that's I couldn't find it.
Oh, yeah, that's
Because
cold.
then I didn't look that hard.
Yeah, snow's cold.
Since when?
Since always.
Wait.
It's not that hard.
I know. I just had it right for I showed you this video.
Oh,
Do you think it matters what font you are? I really want to see if it's real. You said it's probably not, but I really want to see if it's real.
Yeah, I don't think it's real.
Can we try it?
You can try it.
You have a light bulb for this small?
Lou?
It was a normal light bulb.
if it works, give me extra credit.
We have 50.
Oh, yeah. They're up front.
Oh, is that gonna work? Oh. We won't break it, I think. Thank you.
Won't break it.
We'll be back. We'll be back.
Okay.
So,
Wait, guys,
so
we go to the
you're,
library,
like,
let's
actually
just do
doing
it out here in the
something
upper.
green there, like other rules, like more the way you're adding multiplying and all that.
Yeah. We just basically do multiplication, so
Mr. Perrin will teach the other rules.
Okay.
Yeah. And that has to do with how many decimal.
Yeah, how many decimal places there are?
Right.
Because
Which
like
makes
if
sense.
you're adding, you have to keep the same number of decimal places. If you're multiplying, then you take the number of decimal places in the